Good morning. Welcome to this morning's webinar. This is Victoria Beal with the Ohio LTAP Center, and I have with me my colleague Ray Brushhart, who's going to be your presenter on part 2 of the FoRRRwD webinar series that's focusing on reducing rural roadway departures. Hopefully you were able to join us for the first of the webinar series last Thursday, but if not, don't despair. We will have the recording posted and links sent out to everybody by the time we wrap the series up. So with that, I have a couple of housekeeping items, and then I'm going to turn things over to Ray. First off, I'd like for everyone to look for the question section in your GoToWebinar panel. And if you wouldn't mind, I'd like for you to drop me a hi or hello in there. If you've been on my webinars before, and you probably are familiar with this process, but I just want to make sure that everyone knows where that's at, because that is where we are going to be accepting questions from everybody. So the second part of my housekeeping is I want to let you know that in the handout section, I've posted some files for you. Now, don't let the fact that files for sessions 2, 3, and 4 are in there confuse you, because while they're labeled session, they actually are more like lessons within this course. And the session 2 file is the lesson that we left off on partway through on last Thursday. And then on today, Ray is hoping to not only finish that up, but to get through 3 and hopefully even get partway into 4. Just depends on how many questions you guys have. I've also included in there a handout for the FoRRRwD series itself in case you need the links to register for the next 2 sessions. And then I have in there a flyer for an upcoming session we just announced on Ethics for Engineers Jeopardy Style, which is actually going to be hosted by Ted Green from the New Jersey LTAP Center, who is going to be providing that content. So, okay, apparently session 4 PDF is not downloading right. I'll work on getting that replaced while Ray gets things kicked off. So anyway, that's all I had for right now. Ray, you want to go ahead and take things over and get it rolling?
Yes, ma'am. I'm ready to rock and roll. Good morning, everybody. As Victoria was saying, I'm Ray Brushhart. I'll be your host today for this FoRRRwD webinar. And this is our second session. And in our first session, we went over a lot of reasons why we need to have this focus on reducing rural roadway departures, and a lot of crash statistics and things to look at there. And you know, we decided that we need to have a 3-pronged approach on how we reduce these rural roadway departure crashes. And the first approach is we want to do our best to keep the vehicles on the roadway in the first place. If they stay on the road, we're not going to have those type of crashes. And so we have some countermeasures specifically designed to do that. And we began going through those with looking at pavement markings and signage. We didn't get all the way through that, so that's where we left off, and that's where we'll start today. And then the second prong of the approach is to have some countermeasures that help vehicles recover if they do leave their lane of travel. So we have some specific countermeasures to help vehicles get back into their lane without crashing. And then the third approach is to do our best to, you know, we've done everything we can to keep the crash from happening, but the crash happens anyway. So we have some countermeasures that reduce the severity of that crash. And so that's our 3-pronged approach. So let's get back to looking at some of these countermeasures that help us keep vehicles in their lane of travel, keep them on the road. And so we left off with looking at sign retroreflectivity. And so it says that retroreflectivity is critical for nighttime visibility. And let's see here. Let's go back a slide there. If we take a look at these stop signs that are being tested there on the right, which ones do you think will be the most visible at night? As you can see, you've got several of them look like they're pretty faded. So those probably aren't going to do the trick, are they? So if we move the slide, we take a look at those. We can see which ones stand out. Of course, the one in the top row, the second one, is really bright. So I would say that particular stop sign meets the current standards for retroreflectivity. Some of these signs, they're pretty darn bright. In fact, we had a couple of township trustees that participated in our sign grant here that we have at LTAP, and they said, those signs are too bright at night, they blind me. Well, hopefully they don't blind drivers, but what's the opposite of that? To not show up at all. So we have, as you can see there in the bottom, that a lot of those stop signs literally disappear at night. So we definitely don't want that to happen. And so, there are standards you need to meet with retroreflectivity, and there are ways that you can assess or manage, just how good your signs are retroreflective. And so there's two assessment methods. One is a visual nighttime inspection method. And I think it even speaks to having someone that's maybe even a senior citizen can ride around with you to study those. And then there is a measurement method with a device called a retroreflectometer. And so you can use those to see if they meet the standards for retroreflectivity. Another thing about our signs, especially our curved signs, is they need to be easily seen, or it's also called sign conspicuity. And so for signs to be seen both day and night, they need to be aimed toward the approaching traffic. So if we take a look at that top picture, we see that probably the first two chevrons are aimed properly towards approaching traffic, but then the third and fourth one may not be. And so we drive through that curve at night, we can see two chevrons. You can't see the third one, and you can barely see the fourth. So maybe the fourth one will come as you traverse through the curve. Maybe it will become brighter as you drive around it and aim your headlights that way. But that's the thing with chevrons is they need to be aimed at the approaching traffic so the headlights will hit them. And the chevrons need to be in the curve. They need to be seen from both directions. And so they have the device here, as you see, like the butterfly device that you can attach to the post. And so you don't have to double the number of posts. You can use one post to have chevrons aimed in both directions. Another thing we need to be on the lookout for is the vegetation. It's getting to be that time of year where the vegetation is going to be growing, blooming. And so you need to go out there, drive your roadways, and make sure that the vegetation isn't taking over. If so, then you need to remove vegetation. In fact, we have an annual workshop here at LTAP called our Vegetation Management Workshop. But Victoria, I think was that postponed this year? I don't know if she heard me or not.
Ray, you'll have to ask me your question again.
Okay, what was the deal this year with our vegetation management workshop?
It has been, the in-person has been canceled, but I am going to be looking to see if there's any chance of hosting some webinars on vegetation management. I'm working through the requirements right now because those who have pesticide licenses need recertification credits, and I want to make sure that our webinars will meet that requirement. So tell everybody to stay tuned.
Okay, stay tuned, everybody. We'll be making that announcement through our email blast, so make sure you're signed up to receive our emails. Okay, so that bottom left picture clearly shows the vegetation is blocking the view of the warning sign, and it shows warning sign shows the shape of the curve, so it's very important. So we need to clear that vegetation. So here's the list of the crash types that are addressed by pavement markings. You know, they do a really good job of helping to lower your curve crashes, head-on collisions, and nighttime crashes. And you know, the markings include edge and centerline markings, delineators, and raised pavement markings. And you see on the right we have some information from FHWA. They actually have these, they look like playing cards, and they talk about each of these countermeasures, and they have a link on the back of the card that tells you how to read more about those particular edge and centerline markings, whatever the countermeasure is that's on the playing card. So you can go to the FHWA Office of Safety and click on nighttime visibility pavement markings and read more about the benefits that they provide. Okay, so the MUTCD, it talks about all these pavement markings and signs, and Section 3 of the MUTCD is all about our pavement markings. And if you go to Section 3B.01, you can read about the yellow centerline pavement markings and warrants. So the standard for yellow centerline pavement markings is that they shall be placed on all paved urban arterials and collectors that have a traveled way of 20 feet or more in width, with an ADT of 6,000 vehicles per day or greater. Centerline markings shall also be placed, and I said shall, on all paved two-way streets or highways that have 3 or more lanes for moving motor vehicle traffic. So that's the standard. And then it gets into the guidance, and that's when you use the word should. And as you can see on your screen there, it says should be placed on all rural arterials and collectors with a traveled way greater than or equal to 18 feet wide and an ADT greater than or equal to 3,000 vehicles per day. And then we have the edge line marking, the white edge line. It says it shall be placed on rural arterials with a traveled way greater than or equal to 20 feet wide, with an ADT greater than or equal to 6,000 vehicles per day. And then it goes into the guidance, which is markings should be placed on rural arterials with a traveled way greater than or equal to 20 feet wide and an ADT greater than or equal to 3,000 vehicles per day. So there in the guidance, and we're getting down into the realm of a lot of Ohio's 2-lane rural roadways with the ADT.
Hey, Ray, we got a question for you.
Okay.
Is the crash reduction of 22% based on adding edge line or increasing the width 6 inches to 8 inches?
All right, where are we looking at? Is that the previous slide?
Last slide, he said. Yep.
Oh, on the back of the card, crash reductions. So if you merely add, both the edge and centerline markings, the studies showed a 24% reduction in the crashes. And then I'm going to get into that, the wider edge lines here in a minute. So we'll talk more specifically about that. But they gave you the link there that goes into the details of that crash reduction and their data. And the source of that data was the AASHTO Highway Safety Manual, which you can find online, or you can go to the CMF Clearinghouse and read about that as well. Crash Modification Factor Clearinghouse. You can just Google that and go there. Okay, so here we see standards and guidance for the use of centerline and edgeline pavement markings. So it's clear when they are required and when they should be. So if in the should category, it means you should the pavement markings should be there unless you have some really good reason not to have them there. Okay, so then let's talk a little bit more about that. Here's from the Highway Safety Manual that we were just talking about. In this table 13.3-39 says potential crash effect of placing edgeline and centerline markings. Get this straight here. So the picture that you see there is taken from a study that was conducted by FHWA. It's in DuPage County, Illinois. And the study was titled Handbook of Road Safety Measures. Took place back in 2004. And so what this study showed was that they placed edgeline and centerline markings on this 2-lane rural road, and it had a crash modification factor of 0.76, and so that's a 24% crash reduction just for the addition of pavement markings. So just by adding paint on the road, they had a substantial reduction in crashes, all crashes. And then we go to Missouri, which is really going to help us discuss some reasons why we can add edge lines to our low volume Ohio 2-lane roadways. And so back in Missouri in 2008, they looked at well, it says they did not stripe the edge lines on roads with less than 1,000 vehicles a day. So in Missouri, they had a policy to, if you had a roadway that had less than 1,000 vehicles a day, they did not put edge lines on there. And that's probably the case on a lot of our Ohio roads as well. I know I grew up on a pretty busy county road. It has well over 1,000 vehicles a day, and it does not have any pavement markings whatsoever. And so, and they looked at the inventory. They had 18,000 centerline miles of roads that met this in this category of less than 1,000 vehicles a day. And of these, approximately 7,500 centerline miles, 1/3 of that mileage of road had an ADT between 400 to 1,000. And these roads had 219 fatalities and over 1,500 severe injuries in the last 3 years. And it made up 2/3 of all the overall crashes in the state. And so it says Missouri decided to provide edge lines on these roads. They dropped down their policy from 1,000 to greater than 400 vehicles per day. And then they decided to study that. And so they went ahead and reviewed them. Let me get to my chart here, make sure I get this right. Okay, so as you can see on the left, they have different things that they looked at: the severity level of observed crashes before the edge line, and then observed crashes after the edge lines were put in. And then they had a 15.2% decrease in total crashes, and then a 19.3% decrease in fatal and injury crashes. So almost a 20% decrease in crashes by adding edge lines on these, and that's the fatal and injury crashes. So they had a significant impact just by adding edge lines. Okay, so edge lines are pretty important for providing guidance, especially through curves. So if you have some roads where you're not using edge lines on your roadways, maybe it'd be a good idea to at least supply the edge lines throughout your curves.
Hey Ray, a question that came into the question box, and I don't know if this was addressed in the study or not, so maybe you can tell us, was there any difference between the yellow or the white used at night? Was there any, one that was found to be more effective? Or was there any study on that?
That wasn't part of this study because these particular roads, they weren't wide enough to have the center line. You have to have a certain width for the yellow center line. A lot of our really low volume roadways, they're not 20 feet wide. They're not even 18 feet wide. Here in Ohio, we have a lot of 16-foot wide township and county roads. And that's what, these roads were out in Missouri as well.
Okay, another question that came in, somebody wanted to know if you could go back to the percentage of decrease in the crashes. They're saying that the numbers indicate more than 19%.
Well, what they've done here is they began using this Bayes method of the study with the regression to the means and all this stuff that made it, like a real study. And so the results of that are usually more conservative than if you didn't do it that way. So yeah, I agree. It's showing a higher result than that. But when you use this Bayes empirical method of your study analysis, then you come up with more. When you publish your study, it just turns out more conservative. I hope that answered your question. So then let's take a more in-depth look at the white edge lines in our curves. And so they actually have a study where they looked at the standard 4-inch white edge line versus, let's make it 2 inches wider. Let's look at a 6-inch white edge line. And so the results of that study are there at the bottom. It had just by adding 2 inches more white paint, they had a crash reduction factor of 22%. And the quality of the study was a 4-star study. And the reduction was in all crash types. So fatal crashes, serious injury, minor injury, and it was a study on principal arterial other than freeways and expressways in the rural area. So that's a very effective countermeasure, pretty low cost. So when you get to your curves, you should consider widening the white edge line by 2 inches. So then we have our marking enhancement raised pavement markers. So raised pavement markers may supplement or substitute for edge lines and or center lines, reflective or non-reflective in maintenance. So those are the issues that they look like. So your pavement marking lines can be supplemented with raised pavement markings to improve visibility in wet weather. So your raised pavement markers may be used in lieu of long pavement lines. Some agencies use non-reflective for lane lines, and they show a button variation in the right photo. Must be over here. Raised pavement markers are historically difficult to maintain. A key is the adhesive or binder used. And so the binders typically used are hot bitumen or epoxy. And of course, there's maintenance issues, especially where snow plowing is required. So yeah, in Ohio, we've had a problem with snow plows ripping them out.
Ray?
Yeah.
A question that's come in. It says a lot of county roads with widths less than 20 feet. At what width do the edge lines start to have a negative effect?
Well, when you look at the MUTCD, you talk about, if you look here at this screen here on the should, it's just guidance. So you have to have, you don't even want to think about putting them there unless you have 18 feet of pavement. So greater than or equal to 18 feet. So that must be where the negative effect, that must be that line that you're looking for. So, so if you have an 18-foot wide pavement, then yes, you can use your yellow center line, and then it must not want to do that if it gets less than 18 feet wide.
And here's another question, Ray. It's actually come in from the fine university where you graduated from. It said, given human factors are the cause for many crashes up to 90%, do you think the application of some of these countermeasures should account for different driver types? If widening edge lines worked in Missouri, would you think it will have the same impact in Ohio, or the same crash reduction factor or crash modification factor?
Well, that's a good question. I guess the assumption is that it will have the same effect. So
yeah,
what is the driver type they have in Missouri that they don't have here?
Yeah,
I don't understand.
And I might chime in there a little bit too, because I'm somewhat familiar with the Highway Safety Manual, and the fact that you can do a calibration for the crash modification or crash reduction factors based on, Ohio versus another area. I've often spoken with Derek Troyer and the work that they're doing in the safety section to look at making Ohio specific crash modification factors based on the drivers here in our state and the way they react to the roads. But in general, the consensus, from what I understand, is that the crash modification factors are, nationally available and internationally available through the clearinghouse. And then from there, it's up to each area if they want to look at doing a calibration.
Very good.
Sorry, Ray.
No apologies needed for that one. That sounded very good. Okay, so where was I then? So then back to raised pavement markers. And then in the MUTCD, I said, what did I say? I said, when I said raised pavement markers may be used in lieu of long lines, in lieu of means replace. MUTCD uses substituting, so you can substitute the raised pavement markings for the pavement marking, marking lines, the yellow center lines, which, as you can see here in the bottom right curve, they're using those, the button type variation instead of the solid lines. And then, so that's something to look at. And then we have another countermeasure is delineators, and which provide guidance at night and during adverse weather. So when I say delineators, we're talking about these that you see on the screen here. You know, they're a step below the chevron. And so they remain visible when roadway is wet or snow covered. So you have different types of delineators. So they're there to outline the roadway feature like a curve for safety purposes. And it projects or mimics the intended path of the road or shoulder. And FHWA is evaluating the use of delineators that are retroreflective all the way to the ground. So they're even coming up with new products in this area as well. And then if we look in section 3F of the MUTCD, that's where you'll find the information on the application and installation of delineators. Reflective materials such as reflectors, paint, or panels of retroreflective sheeting can be a highly effective treatment for delineating curves, especially at nighttime. Colors should be the same as traditional delineation. For example, the same color as the adjacent edge lines. On a two-way road, this means that the delineation would be white on both sides of the road. And so where are these appropriate? Well, if we look at table 2C5 that we looked at on Thursday, it indicates chevrons are either recommended or optional. And then for all other roadways, delineators may be appropriate based on risk or crash history. And in section 3F.02 to 0.04 gives you direction on the color, size, height, and offset of the type of delineator. So then here's a drawing on the right, a picture from the MUTCD showing examples of delineator placement. So we have, we also have a drawing showing chevron placement, but here's a drawing showing delineator placement. So they should be placed at a constant distance from the roadway edge, except that when an obstruction exists near the pavement edge, the line of delineator should make a smooth transition to the inside of the obstruction. So over here, they say you have a range of 2 to 8 feet outside of roadway edge or face of curb. Same way with the inside of the curve, 2 to 8 feet outside the shoulder edge. And they even show where if you have guardrail present, how it interfaces with the guardrail. So there's where you would find the guidance for the use of delineators versus chevrons. And then we have delineators that you can attach to your guardrail. And so you have different types of guardrail delineators. You can see 2 different types there in the first 2 pictures. And then on the third picture, you see how they really light up at nighttime to provide guidance through the curve. And so,
Ray, a couple questions that have come in.
Okay. All right.
One person would like to know your thoughts on using RPMs on the edge line. And then someone else wanted to know that between the delineator and the chevrons, which do you feel is more appropriate for curve delineation?
Well, the second question about which is more appropriate had to do with this chart, table 2C5 that we went over. So sometimes the chevrons, that chart will show you that you don't really have a choice. It's recommended when they are recommended or required, then the chevrons definitely provide better guidance. But sometimes when you look at that chart, it might be optional or something like that. Then you would have a choice at that point based upon, engineering judgment on your part, traffic volume and maybe speed or crash history or something like that. Because obviously the chevrons are going to be a little more expensive than the delineators. And what was the first question?
I knew you were going to ask me that. What are your thoughts on using RPMs on the Edgeline?
Yeah, there's going to be some thought, some thought go into that, and the type of raised pavement marker, and what is your, they talked about maintenance as far as you're plowing snow and things like that, and how you install them. Looks like they have an example of a recessed pavement marker there. Maybe that would be a thing to consider. So I guess, just the roadway that you're thinking about installing them with, think about the what the maintenance is on that roadway, and if you don't want to install something if it's just going to get ripped out, right? We do have some other countermeasures that that you might consider instead of that. But when we get to rumbles, we talk about rumble stripes, and when you have the rumbles on the white edge line itself, it actually provides some retroreflective feedback to the motorist even during wet conditions. And so, of course, they have to be, the white edge line has to be retroreflective. So it's just a matter of, which one do you think would be best on that particular roadway? But I definitely recommend going to the FHWA website and reading about the different products and different studies that's been done in different locations. Hopefully that helped. Okay, so in this case, you can see how the guardrail delineators provide very good guidance through the curve at night. And so the MUTCD allows delineators to be placed on your guardrail as an option, either right in the face of the barrier or on top of the barrier, even though height and offset may not match installation guidance. And they have butterfly type delineators mounted inside the guardrail, are not advised for installation under a post bolt head, as it may adversely affect the performance of the guardrail. So that's something to think about. Delineators can be attached to concrete and metal traffic barriers to provide linear reflectorization and alert drivers to approaching curbs. So that's something to think about. Then we have marking retroreflectivity. So the pavement markings. Take a look here. So the MUTCD says all markings that must be visible at night shall be retroreflective unless ambient illumination assures that the markings are adequately visible. Pavement markings are made retroreflective by adding glass beads or other optics. And the retroreflectivity degrades quicker than the marking material. So that's section 3A.02 in MUTCD gives you the standard that I read there on that first bullet. And then 3A.03 discusses maintaining minimum pavement marking retroreflectivity is reserved for future text based on FHWA rulemaking. And so if you want to see more on that, you'd have to go to the FHWA Office of Safety and look under night visibility pavement markings for more information. So apparently that's going to be one of the changes in the next edition of the MUTCD, which frankly can't get here fast enough, right, folks? Okay, We discussed that in the STEP webinar. Okay, so then we have advanced marking for curves. So here's some options we have for pavement markings that you may or may not have seen. So there's some, you can write words on the pavement. So we have the curve ahead, and they have some other variations here. But if we look in the MUTCD under section 3B.15, it covers transverse or in-lane markings, symbols, lines, or words that are placed in a lane rather than between lanes or at the edge of a lane. So these markings should not be installed unless a sign is in place. Markings of this type always supplement, not substitute for a warning sign. Pavement markings in advance of horizontal curves provide highly conspicuous supplementary warning information and the potential to increase safety. In particular, advisory speed warnings provide essential information directly related to drivers' safe negotiation of curves. Legends of any kind are permitted. Maintenance is problematic due to loss of material in wheel paths. Consider spacing and distance from the curve. Remember, markings supplement signings, so make sure your signing is in place. There's no established guideline for when to use this treatment. It's probably more appropriate for higher speed roads and those where speed studies indicate excessive speeding. However, motorcyclists have been known to slide on pavement markings, so be cautious with this application, but there are options for a more skid-resistant marking available on the market. And so there was an actual NCHRP report, which was number 600, and they looked at speed reduction in horizontal curves, and they had an on-road study of horizontal signing to reduce, let me see, where was I here? To reduce speeds before horizontal curves. And so they had a study conducted by Chrysler and Schrock, and they found that if they had the words curve 55 mile per hour on the pavement, it reduced speeds on a rural road by approximately 4 miles per hour, more than the control treatment. Although this finding was not statistically significant, the benefit from this marking was greater than for the curve ahead text, which did not cause a significant reduction. And then they went on to say that when the curve, arrow, and 50 mile per hour text were tested on an urban roadway, vehicles significantly reduced their speeds by 10% at the entrance to the curve. There was also an 11% to 20% reduction in vehicles exceeding the speed limit. Note that the curve, arrow, and 50 mile per hour text were tested in a section of the road following a vertical crest, so the arrow provided additional information about the direction of the curve after drivers came over the crest. Another option, if advisory speeds cannot be displayed, is the text slow with a curve arrow. And then there was a study done by Retting and Farmer. They tested this marking on a suburban road and found that it significantly reduced the percentage of drivers exceeding the speed limit by more than 5 miles per hour during the daytime and late night time frames, but not during the evening. That's kind of wild. Overall, the markings that provided advisory speeds or an action performed most effectively. Okay, so there has been significant studies done on the use of these the in-lane pavement marking, the words. And so there are some design guidelines for there. You see at the bottom, the goal was to reduce the speeds in the horizontal curves. They have different variations from a curve arrow and the advisory speed, or transverse lines, or the curve ahead. So again, that was, you can find this information in NCHRP report 600. human factors guidelines for road systems. So here's some other examples of speed reduction markings. I know we've tried these here in Ohio. So these speed reduction markings give drivers the illusion they're traveling faster than they really are. And so down at the bottom of the screen, you can see how the spacing between this treatment, as you approach the curve, they get closer together. And so as you're traveling at a certain speed, the lines begin to move past you faster, so it gives you the illusion that you're traveling faster than you really are, so you slow down. And so there, you can read more about some of these treatments at these either the link to the Office of FHWA Office of Safety, which goes over the proven countermeasures, enhanced delineation, and also the FHWA publication called Low Cost Treatments for Horizontal Curve Safety, which was published in 2016. Okay, so let's see what we've learned here. So I'm going to ask you some questions, and you type some answers into the chat box. Is that where they type it, Victoria?
No, the question box, Ray.
Question
and then
box.
I'll read it off.
Okay, so the question is, what countermeasures did we discuss to reduce roadway departures? Let's see here.
Edgeline widening is one. Chevrons, delineators, signing, pavement markings, RPMs, center line markings, signs, stripes.
All right, very good.
Signs, RPMs, rumble strips, barrier reflectors, edgeline signs, delineators, chevron, RPM, center lines. They were paying attention, right?
They were.
Absolutely.
See there, advanced curb signing and advisory speed plaques, chevrons, edge lines, center lines, and delineation. All right, very good. Okay, let's ask another question. You can just type A, B, C, or D. Which of the following is true? So it could be more than one. Which of the following is true regarding the MUTCD requirements for signing and markings? So A says the MUTCD requires edge lines on all roads. And B is, in some cases, it may be appropriate to use signing and marking even if it isn't required by the MUTCD.
They're answering that one, but I want to read off one that came in right at the end of the last question. That somebody put in tricky hash mark speed up. Tricky hash mark speed up markings. I believe those are called optical speed bars. It's where it gives you the illusion that you are going faster than what you are to make you slow down. So, all right. So on your question, they're like BC, 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 BC. Oh, some people put in D. So it's B, C, and D are the answers I've seen so far.
All right, let's see. Well, so it's not A. The MUTCD does not require edge lines on all roads. I was going to say, because I grew up on a road that would be in trouble. Okay, so B, that is the case. So it may be appropriate to use signing and marking even if it is not required by the MUTCD. So remember, if it's required, that means that it's a standard. So then there's also guidance and options involved in each one of these treatments. Markings that must be visible at night are required to be retroreflective. That is true. At all curves where an advanced warning sign is required, chevrons are also required. So that's not the case because remember we had that table 2C-5 and it goes over what is required or what's optional or recommended for each case. Okay, how about this one? Which of these are enhancements that can be made to improve safety? A, B, C, D, E, and F. Are we getting some answers?
Yes, and I just figured out where my mute button was again. Sorry about that. A, B, D, F, A, E, F, D, E, F.
All right, let's see what we got here. So doubling up the advanced warning signs, we saw some pictures of that. So we had our advanced warning signs on both sides of the road. Fluorescent yellow prismatic sheeting. Yeah, I mean, just following the standard for retroreflectivity. That tells us right there how important it is. It's a standard. Use a red background on warning signs. So that's a no, because the color for warning signs is yellow. So making it red does not make it safer. A wider edge line. Yes, we looked at that. Going from 4 inches to 6 inches wide, especially throughout the curve. Placing chevrons on both sides of the road. That's a no, because if you just look at the chevron, it's the shape of like an arrowhead. So if it was on both sides of the road, what would it be showing? It could be pointing in the wrong direction. People might drive on the other side of it at night. And if you flipped it so that it's pointing the other way, then they would think that the curve might go to the other direction. So we want the chevrons to be on
there was a question about why not E in here. So, and I have to echo that. I've actually seen where someone put the chevrons on the inside of a curve, which just confuses the heck out of you as a driver.
Yeah, it might not confuse everybody, but the people that live there and drive that road all the time. But we got to look out for the unfamiliar driver at night. And then using delineators and curves where chevrons are not required. So that's a yes. And we talked about that and where it was in the MUTCD, and talking about where it says where chevrons are not required. Again, that's in reference to table 2C-5 in the MUTCD. Okay, so let's continue with some more questions. A knowledge post test. What treatments to reduce roadway departures are present? And then the second question is, what factors are present that make this treatment critical at this location?
Well, the first person responded right off the bat, said there's an optical illusion that the road continues straight. And I agree with her. I call this a visual trap myself.
Yes,
and other people are saying signing and striping, the curve warning sign, the curve warning sign with the advisory plaque, the edge lines, the warning sign.
All very good. Let's see here. Did I have anything above that? Yeah, edge lines and center lines, advanced warning and advisory speed plaque. What treatments are not present? Maybe chevrons. Maybe they're required, maybe not. What makes the advanced warning sign particularly critical at this location is because the utility poles on the left side of the road, they continue straight. And so they give the appearance that the road is going straight. And then we have a slight crest vertical curve right here that restricts the sight distance so that you can't see the curve that's up here.
Yeah, Ray, if it was me, I would probably go one step further. If that line of snow is an actual road that continued on, I
Mhm.
would probably take a look at that curve sign and adding an intersecting road into the curve to make
Yeah,
people aware that there was an intersecting road coming in. It
yeah,
just depends if that's a road or not.
yeah. It's hard to tell. Kind of looks like it might be, but you also see off to the far left of this picture in the foreground that the snow is deep right there. Maybe that just continues down through there. I don't know what's going on there. Okay, so I think that's it. Do we have any other specific questions for this section?
Not for this section. And time flies when you're having fun. We've got 35 minutes left this morning.
I know we need to delve into our next section, section 3. So we'll get rid of that. And let's look for 3 here. It's this one. I didn't get to the beginning there. All right, so our next topic, it's another countermeasure that we have that helps us keep vehicles on the road. And it's called pavement friction. So turns out friction is pretty important as we drive through a curve. So our learning outcomes for this section will be at the end of this, you'll be able to identify locations with increased friction demand, and you'll be able to name the unique components of the high friction surface treatment, or HFST countermeasure, and you'll be able to recognize the crash reduction potential for high friction surface treatments. So apparently, we want you to know all about high friction surface treatments, and above and beyond that, to actually use that treatment on your roadways and your curves. All right, so let's do a knowledge pre-test in this area. Okay, so here we have in this picture a 2-lane curvy rural highway with an ADT of around 4,000. The curve radius is 280 feet, and it has an advisory speed of 30 miles per hour. And they've had a crash problem there, and they've gone ahead and implemented some countermeasures. They did a 1-inch open grade asphalt pavement treatment, and as you can see, they double stacked the chevrons here, and they doubled the number of speed warning signs. They got the advisory signs on and warning signs on both sides. They implemented centerline rumble strips. So this double yellow centerline has rumbles on it. So above and beyond that, they're thinking, well, if this doesn't work, then we're going to have to consider realignment of the roadway, which could cost up to $500,000. So some of the crashes that they looked at, they had approximately 30 crashes when the roadway was wet. And so in a 4-year period, they had 30 wet crashes. And total crashes and injury rates were 18.3 and 9.7 times the statewide average. And given the average collision rate for 2-lane rural roadways and the ADT it has, it should average only 2 crashes over a 4-year period. So then the question is, what do you think could be done in a short period of time that would cost significantly less than the $500,000 curve realignment project? Can you think of anything else that we could do?
Okay, we have comments, microsurface it, scarifying the pavement, increased friction. And someone had actually, while you were talking, added in that they felt that the high cliff probably precluded sun from hitting the pavement. So if it was in a snowy area of the country, icing would also be an issue. Someone else put widen the edge line, improve the super elevation.
Well, improving the super elevation, that's probably going to be costly. But I heard the answers in there. So, you know, the answer here would be increase the friction. So adding a high friction surface treatment is the answer we're looking for. And depending on, you know, which, you know, I heard everything from scarifying to, which might be the same thing as a diamond grade treatment that you see sometimes on as you approach highway interchanges. Have you ever driven? You see the ODOT goes out there and does this beautiful resurfacing of our interchanges on I-70 or 270, and then you come back through there a week later and you see the beautiful top surface of the pavement's all roughed up, it's gone. Well, that's a friction treatment that we do at our interchanges, and I'll be telling you why we do that as we go through this session 3. So here are some skid related crash factors: tire issues, weather conditions, aggregate friction characteristics. You know, the aggregate in the pavement becomes worn and it loses its friction value. Or maybe it's a matter of bond capability of the pavement binder, or maybe it's a problem with what's called friction demand. So we see a picture here of a wet roadway as it goes through a curve. So let's get all scientific now and talk about pavement friction and the crash risk relationship. Okay, so first off, there's several resources from FHWA and AASHTO, and I'm going to give you all of those here in a minute, but they talk about pavement friction and the need for it, and you know, treatments and things like that. So this book over here from AASHTO, the Guide for Pavement Friction, it goes over a lot of very good information. The problem is it costs a lot of money. So they came out with a new one that's for web only that you can download for free. How's that? So here's a document from NCHRP, the Guide for Pavement Friction. So you can just Google that, web only document 108, and you can download that and read it. So this is the source material for that more expensive AASHTO guide for pavement friction. And on page 78 of this NCHRP guide, it shows some information from the state of Maryland. It said that sites without any geometrical constraints are categorized as low frictional demand sites, while sites with geometrical constraints, such as railroad crossings, traffic lights, pedestrian crossings, roundabouts, stop and yield controlled intersections, curves, and freeway entrance and exit ramps are categorized as high frictional demand sites. So the chart over here on the right, it's got your skid resistance levels as your x-axis, and it has your accident risk, accidents per, gee whiz, 10 to the 8th power vehicles per kilometer. And so we can see as the skid resistance values increases down here on the x-axis from 0.3 to 0.6, the crashes or accidents decrease. So you can double the skid. If you double the skid resistance, you'll cut your crashes in half. So that's what we're shooting for here. We need to, you know, skid resistance and friction, you know, those are pretty much the same thing. And some contributing factors for friction demand, maybe it's the roadway, like a curve, or locations where braking occurs, like intersections, vehicle speeds, driver actions, and trucks. the big trucks, 18-wheelers. This picture on the right is a location where they just couldn't figure out how to lower the crashes. They tried all sorts of things. They got your raised pavement markers here that create a rumble effect, and you're going downhill into a tight curve to a signalized intersection. So there's no room for error if you lose it here on this curve. So let's talk about more of the science, what's going on as we drive through a curve, especially at high speed. So if we look in the AASHTO Green Book, it gives us this AASHTO horizontal curve design model. And some of the factors here are the radius of the curve, the speed of the vehicle, which is your velocity, and then this E represents the super elevation of the curve, and F represents the side friction factor. And then the PC in this line, this blue line, that is the point of curvature. So that the car is going in a straight line until it gets to this blue line, and that's where the curve begins. So the beginning of the curvature. And so when a vehicle moves in a circular path, that means it's going through a radius of a curve, it undergoes centripetal acceleration. And that's only if there's a super elevation in the curve. And centripetal means it's a force pulling you to the inside of the curve. So in this picture up here on the top right, it's showing a curve with super elevation. Now, we all know that in Ohio, a lot of our county and township roads, or even some of our 2-lane rural state routes, they don't have any super elevation. If you're driving on the interstates and go through a curve, then yeah, we have super elevation there. But a lot of our 2-lane rural roads just evolved over time from deer trails to horse trails to horse and buggy, and then we paved it for cars. So there is you can't find a construction plan that shows you what is the super elevation in a lot of our county and township roads or low volume state routes. And so as you look at this equation, if we convert it to put the super elevation and the friction on this side of the equation, if we have no super elevation, then all we left is friction that's holding our vehicles on the road. So if we overcome the friction factor, then that's when we go into a skid, because there's no super elevation helping us. There's no forces helping to pull the vehicle into the inside of the curve. All the forces are forcing the vehicle off to the outside of the curve. Like that's centrifugal force at that point. So it's like if you tied a string to a rock and you flung it, that's how you would feel the centrifugal force. So you're getting slingshotted off of the side of the road there at that point. So this the AASHTO model here, although it has a theoretical basis that the curve design should avoid loss of control due to skidding, the actual controlling values are based on an operation model of providing a level of comfort to drivers. And plus, vehicles a lot of times they hit the brakes just after the point of curvature, and the road is transitioning from a normal crown to a super if there is super elevation. So vehicles are experiencing side friction as well as braking friction at that point. And so if we look back to what our objectives here, we want to reduce the likelihood of a vehicle leaving its lane and either crossing the roadway center line or leaving the roadway at a horizontal curve. And so, a lot of run off the road crashes happen in curves, but also leaving your lane. A lot of head-on collisions happen in curves as well because people skidded or lost control. They couldn't stay in their lane. And so let's take a look at the curve design model from AASHTO versus reality. So what side is this one here? Okay, so the functional basis for the AASHTO curve design model, that equation you saw, is driver comfort. And so this slide points out what a few engineers understand, the real techie engineers. The design model values are based on studies of the behavior of drivers at high speeds through curves. The friction factors, they're really not friction factors, they're actually comfort factors. A true friction factor would relate to the pavement and tire interface, but that's not how the AASHTO friction values were derived. If we look at the MUTCD, it says the advisory speed may be the 85th percentile speed of free-flowing traffic, or the speed corresponding to a 16-degree ball bank indicator reading, or speed otherwise determined by an engineering study. And if we go back into the 1930s, that's where a lot of these original advisory speeds were developed that you see on some of our low volume county and township roads or low volume state routes. A lot of those, so whatever they put up as the advisory speed back then, that's what it still is today a lot of times. That's one of the reasons why with our LTAP sign grant, we purchased several digital ball bank indicators. We want all these curves restudied so that they are more appropriate for today's vehicles. And so this report down here at the bottom right, NCHRP Report 500, Volume 7. Again, there's multiple volumes, each dealing with different problems. But this one is a guide for reducing collisions on horizontal curves. So it says some of the summary of issues that they looked at in that volume may cause the AASHTO design formula to underestimate certain operating conditions. So there's the theoretical design model, and then there's the reality that, like in Report 500, Volume 7 looked at, and it says that the likelihood of skidding increases when these assumptions that are used in the AASHTO model are violated. And those assumptions are there on the left, that the basis of driver comfort assumes that the vehicles do not exceed the design speed and that the vehicles traverse the curve following a constant radius. And so that's another thing that this volume 7 looked at or discovered, is that several studies have shown that under real world conditions, both of those assumptions are violated. So let's look further into the conceptual relationship between friction demand, speed, and friction availability. You have a certain friction demand, but do you have that much friction available? And so this chart, it shows you the pavement tire friction capability of the roadway. And then as the vehicle speed increases, so does your friction demand. And so there where the two lines intersect, that is the point of impending skid. So your vehicle has gone to a certain the high enough speed that it has reached the point of the pavement tire friction capability. And then once it exceeds that, then that's where the vehicle goes into a skid. So we have there are some common methods to restore or add friction. Some of the ones you're probably familiar with are a thin hot mix asphalt overlay. So your fresh asphalt will immediately improve friction, but it may not last that long, may only last a few years before the friction levels drop again because the aggregate becomes worn. Then you have your open graded friction course, and then an ultra thin bonded wearing course, which is maybe a ½ inch to 3/4 of an inch thick. It seals and protects underlying pavement. It's a non-structural layer, and the emulsion layer is applied before the wearing course. Then there's slurry seals or micro-surfacing. Micro-surfacing is kind of a popular treatment for this. It improves friction, and it mitigates raveling or oxidation, and it looks really good when you put it down. It's a mixture of polymer modified asphalt, emulsion, water, fine aggregate, and mineral filler that is mixed into a slurry and applied in a thin layer. So it's similar to a slurry seal, but it's more durable. And then a lot of our county and township roads are chip sealed or a seal coat. And then we have our diamond grinding, which is what we have on what you would see at our major highway interchanges. The reason for that is because we discovered if we don't add a friction treatment to those interchanges, then we've all seen it happen where 18-wheelers, we see them tip over on their sides. They usually do that during rush hour, right? Well, the reason we found that they do that most of the time is that they actually went into a skid before they tipped over. So the theory is if we can prevent the skid, they won't tip over. And so that's why we do that diamond grinding treatment at our interchanges. And then there's grooving treatments to add friction, which are narrow grooves that are saw cut in the direction of the traffic, about 3/4 of an inch apart. It improves the texture and provides a path for water drainage as well. And then we have our high friction surface treatments. And then that's a specialty pavement treatment that's used specifically to restore or enhance friction at spot locations like curves. And it uses a resin binder and polish resistant aggregates. So not just the typical aggregate that we use here in Ohio, but something that won't polish as quickly as like our limestone that we have here. So any of these methods may be appropriate depending on the definition of your problem. But we're going to be focusing on the high friction surface treatment because, as we will learn, it provides the most benefit, hands down, compared to all the others. So what makes up a high friction surface treatment? Well, it's the polymer resin binder and the aggregate. So there's 3 types of these resins. They're epoxy, polyester, or acrylic. And then the aggregate that we like to use, we want to talk about, is called calcined bauxite. And so, the binders, they lock the aggregate in place and provide the needed tensile strength to transmit the vehicle load to the pavement below. And in the aggregate is this calcined bauxite, which provides the highest resistance to polishing and friction durability. Bauxite is available from Arkansas, but it's now being calcined in Alabama. So there's a local U.S. source for the aggregate. It used to be we'd have to get it from places like India or China, so it wasn't very cost effective, but now it's becoming more common to get it within the U.S., and so the prices are starting to drop, which is good. So the high friction surface treatment resists polishing or wearing down when compared to other aggregates, and it's a high quality binder. The binders improve aggregate retention. And so as you can see in the pictures how they're putting it down, they put the layer of resin down, and then they of different ways or methods to get the aggregate to get embedded into the binder. And so let's take a look here at this video here. And so the cars are going the same speed. They're told to brake at the same point. And you can see with the bauxite treatment, the difference it made being able to stop quicker. So reduction of 25 to 30% stopping distance. So let me see here. So where can friction benefit safety? Well, we want to take a look at our high crash locations that have wet weather related crashes or high friction demand locations. And of course, that's our curves, right? Let me see here. I want to take a quick minute here, Victoria, so I'll be right back.
Oh, while Ray's doing that, I'm just going to go ahead and chime in on the fact that we do have a number of other webinars coming up, and I'll share with you some of the ones that we do have that you might be interested in. Tomorrow, actually, we have a GIS crash analysis tool GCAT webinar that's going to be in the morning. And then we have a TIMS webinar in the afternoon. If you're interested, we have the subject matter experts for both of those software available, and we'll be presenting on those webinars. I called it our double header because I know we're all missing baseball season. All right, Ray, you good?
Sorry about that. Yeah.
Okay.
Okay, so where was I here? So what else we got here? We got maybe in places where you have poor pavements that have marginal friction caused by the weather, or the friction values are not compatible with the approach speeds and geometrics. And of course, you guessed it, we want to focus on areas where there's horizontal curves, but also approach to intersections and downhill grades. We saw that picture at the beginning of this presentation. It had all three of those in one location. It had a curve and a downhill, and it was the approach to an intersection. So you can imagine the friction demand at that location. And so, you know, a lot of studies have been done, but this one was from Texas A&M. They do a lot of research for AASHTO, and so they have a recommended distance ahead of the point of curvature to where you begin your high friction surface treatment application. So they're based on the approach speed and the advisory speed for the curve. And so, you know, the distances here before the point of curvature. So if like a 55 mile per hour curve with an advisory speed of 35, you would need to begin treatment 230 feet before the curve. And 35 would be a little shorter, 194, etc. So those are some examples. Like a lot of our township and county roads are 55 miles per hour with 35 mile per hour advisory speed. So there's your how far in advance that you would want to begin that treatment. Let's take a look here at an example of a positive outcome by the use of this high friction surface treatment where the Pennsylvania Department of Transportation was involved. I'll make sure I got my volume turned up here so you can make sure you can hear it real good.
We're not hearing anything, Ray. Okay.
Oh, I didn't start it yet. Now I'm going to start it.
Okay.
About using high friction surface treatment. We chose this particular curve because it's unique crash history. It was the majority of crashes were occurring in wet conditions. In fact, over a 3-year period, there were 26 crashes.
Since I've been here as the chief of police, this intersection has been very problematic for us. We frequently would have to park a marked unit there with the emergency lights on to try to slow people down. It was not the speed that the vehicles were traveling. It was the road surface being wet that contributed to the accidents. We contacted the Pennsylvania Department of Transportation, spoke with Steve Ohowski, an engineer, and we worked together to come up with some kind of a solution.
I've been doing low-cost safety improvements for over 10 years, and I've never seen such an immediate positive response to a safety treatment. In our use of high-friction surface treatment on curves, we've seen a day and night difference in accident reduction and even an elimination. Quite simply, it stops crashes from occurring.
Absolutely consider this road surface material. This eliminated our accidents. Since the material's been applied, we've had, I believe, only one reportable accident at that location. So it basically eliminated all accidents there.
Okay. Did you hear that good, Victoria?
Yes, I did.
Okay,
And
good.
you have 4 minutes left.
All right, so here's some data from that particular project between October 2009 October 2012. They had 26 crashes, and then after the treatment from November 2012 to November 2015, they had 1 crash. And the skid resistance factor in September 2012 was a 22. You know, you want a roadway to have at least 40, and then upwards of 60 is very good. But with the bauxite treatment in November 2012, they measured it as a 75. So that's sort of a pretty good crash reduction there. They've used this in several places by now. You know, the first places they used it was probably Kentucky and North Carolina, and then Florida came along and started using it. And they began to, of course, after they use it, conduct some after studies as well. So here's some before and after crash rates with the high friction surface treatments on tight curves. So the over here is the average crashes per million vehicles. And then at the bottom, they're showing total crashes and also wet weather crashes. So the darker blue is before the high friction treatment. So there were 1 crash per million vehicles miles traveled before, and they lowered it to 0.6 after. And in the wet weather crashes, went from 0.6 to 0.1. And you can read more about that. To get to this document, you can go to the link. In case you forgot, all my slides are in the handout portion on your screen, so you can download those to your computer, and each one shows a link to the information that I got the data from. So that's
Ray, there was a comment that came in the question box. I just have to read this because
okay.
I love roundabouts. They said needs a roundabout.
Wait, what's that again about the roundabout?
It needs a roundabout.
Oh, that intersection needed a roundabout. Maybe so.
So since we are up on 11:30, I want to be respectful of everybody's time. And Ray did mention that the handouts for what he's covered today are in the handout section. There was an issue with the information for session number 4, which is kind of like lesson 4. It's not actually the session 4 of the webinar series that we have planned for next Tuesday. So on Thursday, when hopefully all of you are back on here, we'll have the handout for session 3, which Ray will be finishing up on Thursday, and then an updated version of the session 4 file in there that can actually be opened, hopefully without any errors. So, all right, I want to thank everybody for being here. Please make sure you stay safe, and Ray and I will look forward to seeing you on Thursday.
All right, everybody, have a good day and see you Thursday.